Thursday the 24th. Second funniest day of the month. Okay? SWBA, students will be able to plot points, functions, and relations. Section 4.1. Mr. Costa, how do we jump from 0 to 4 on units? Great question, math students. Thanks for asking, okay? Chapter 0 was what I just dubbed a review chapter. I called it 0 because it's not actually part of the curriculum, but I put it in there for us to jumpstart off the year. You actually left off in Algebra 1A, I don't know if you all remember, before you went to remote learning, on Chapter 3, solving linear inequalities. Okay?
Yeah.
Okay, inequalities and absolute value. So we're picking up where you left off before the remote learning by doing the next chapter, Chapter 4. Does that make sense? I like to think so. Can you drop a core class?
Yes.
Not successfully. Alrighty, continuing on. So, we have this thing. It's called the coordinate plane. Have you guys heard of it? Okay, it's not like an airplane. You're like, okay, it's coordinate plane. Where coordinates go, even though it's spelled the same. So we have some different things on this coordinate plane. Who can tell me something I might be able to, who can tell me the name of a part of the coordinate plane here? Okay, Hannah. The x-axis. Which one is the x-axis? Show me with your hands. Up or down or left and right? It is left and right. Very good. This is the x-axis. Okay? Oh, what am I doing? Okay? Who can tell me another part of the coordinate plane? Okay, Tucker. Okay, which one's that? It goes the up and down. So this is the y-axis. Okay? I'm trying out my iPad. Okay? So I have this iPad. The school is having me use the test kind of pilot what's happening here and trying this instead of Promethean boards because obviously Promethean boards have some issues. We know those things. And so trying this out to see kind of how it goes. So we'll kind of see how it goes and continue from there. What's something else we could label on this coordinate plane? Maybe a specific point.
Your name?
Okay. Oh, I could put my name on there. That's not the coordinate plane, but Mayamo Senior Castle. Okay, Abby?
0.
0, 0, 0. What's 0, 0 called?
I can't remember. Oh my gosh, I know it. Origin.
Origin. And it is 0, 0. It's an ordered pair. Okay. And Lainey was talking about negatives, right? We have left and right negatives over here for the x-axis, negatives down here for the y-axis, right? Okay. Yes, sir. Okay. Questions on that, on the coordinate plane?
No.
All right, we're on to section B of this. We finished section A already. That was quick. Okay. Section B, ordered pairs. Each point on the coordinate plane, every single point on here, infinitely many points, has an ordered pair. Ordered pairs are written how? X, comma, Y. X, comma, Y. Okay, you have the X value, comma, then you have the Y value. X value deals with which? Left to right or up or down?
Up and down.
X deals with left to right or up and down? Left and right, left and right. The x-axis goes left and right. The x value is left and right. Y value is the up and down. Okay? So, graph the following points. A, 4, 2. B, 0, -5. C, -4, 9. And D, -3, -7. I want you guys to try plotting them on this graph. When you have it or have questions, raise your hand.
4 and up 2.
Right 4, up 2. So we go right 4, and then we go up 2. And that will be point A, if my pencil will decide to work right now. There we go. Point A will be at 4 to the right, 2, up. We always do X, Y. It's alphabetical.
Put your phone away.
Okay? Oh, my. Okay, my bad. Okay. B, point B. Can someone help me where to go with that? New person, Lainey.
Start at 0.
Okay?
And then you go down 5.
Okay, down 5. And I don't go left to right at all, do I?
What?
I don't go left to right at all, do I? No, because it's 0. Okay, 0, -5, you just go 5 straight down. Okay, C, -4, 9. Different person that wants to help me with this one. C, -4, 9. -4, 9. Maddie.
Go over 4.
-4, which direction?
Left.
Left, okay.
Yep, up 9.
And up 9. Now I'm going slightly off the graph. Okay, and this is letter C. Very good, point C. Okay, well, there's only 8 spots, so it goes up 1, 2, 3, 4, 5, 6, 7, 8. So where should 9 be? Up here. Okay. So D, -3, -7. Who can help me with this one? Emily, thanks for volunteering. Where would I go?
Left 3 times down 7.
Okay, left 3, down 7. We'd be down here. Letter D, as in doggo. Okay, questions on this and how we pull out these points.
I just realized it was alphabetical order.
That's intentional, right? Right? Okay, our alphabet matters, okay? Alrighty. So, we just finished section B. On to section C. Relations. Okay? We're not talking about that you're in a relationship and you're swapping hoodies. Okay? We're talking... What? Who said I was talking about you?
Because you always make fun of me.
I don't know about that. Okay. So a relation is a set of ordered pairs. Okay, so it's going to be a set of ordered pairs. So we're going to put relation on that line. So here is a set of ordered pairs. Notice inside these two brackets, or these braces, inside these two braces, the ones with the squiggly lines, we have 4 sets of ordered pairs. And inside they're separated by commas. We have these braces here, the squiggly ones, okay, they're to show or signify, okay, or show, label, that this is a set. Okay, this is a set of ordered pairs. Okay, Mason.
Never mind.
If you think of it later, feel free, okay?
I know it. I just don't.
Okay. So, does anyone know what we call the set of all the x values? Okay, it's called the domain. Does that sound familiar at all? Nope. Okay. Domain is the set of all the first coordinates of a relation. But the first coordinates are always the x values because it always goes x comma y. Now, sometimes we'll write the domain. We'll say the domain of this relation is blank, 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 blank. And we will always order them from smallest to largest, writing each value once. So if I were to say, what is the domain of this relation? We have this relation up above here. What is the domain of that relation from least to greatest? Lainey.
-1, 1, -3. Wait.
Wait, what? No, what are you going to do? What are you going to do?
Hold on.
Is it -3, -1 more?
Okay, there you go. I agree with that. Why'd you change it, Lainey?
Because -3 is smaller than
Because -3 is smaller. And you don't have to repeat the +1 because you put everyone once. So I will put a capital D to show that I'm doing my domain. Then I'm going to put a colon to say, hey, here is my domain. Then I'm going to put the braces to say, here's my set of numbers. Okay, it's all very technical. It's all very technical. And then here is my list of numbers. Go ahead and write that down now there. Okay? Go ahead and write that down now there. So my domain is -3, -1, and 1. And yes, we do need those braces, the squigglies. If you're not very good at drawing them, continue practicing, please, and thank you.
It looks like a 3.
Okay.
Mine does.
All right, so alongside domain, we have this thing called the range. Now, if domain was the set of all the x values, what do we think the range will be? The y values. The range is the y values. Once again, smallest to largest, writing each value once. Those rules did not change. Now, if we used a capital D for domain, what letter do we think we're going to use for range? Reagan. Oh, capital R. You nailed it. So I'd say my range is what? What would be my range if I use this relation, this set of ordered pairs up here? Tucker, go ahead. 1, 2, 3. We don't have to repeat that 3 even though we see it twice because you only put them once. It would actually be wrong if we repeated the 3. We don't care how many times we show up. We just want it to know that it is there at all. Questions on that? Dank, Dope, and Liddy. Alrighty, let's flip the page. Man, we're already on letter D. Hey, we're flying through this.
Is it the whole alphabet?
No, we won't go through the whole alphabet.
Oh.
We only go to G.
Yes.
What?
What?
Crap.
Yeah, because
What is it though?
It is.
Oh, okay. That seems a little like exaggeration, but okay.
Yeah,
Is it not?
Classic teenagers with drama. All right. D, representing relations. There are many ways to show relations. Here are a few. Ordered pairs. So, we can put the ordered pairs here to show a relation. We can say these 3 points are together in a set. They're in a relation, okay? And that was what we did on the last slide. Another way is to use an XY table. For an XY table, you put the coordinates lining up. You put the X with the corresponding Y. What does corresponding mean? What does it mean if two things correspond?
Working together?
Okay, they work together. They kind of go together. Okay, they go together. Okay, the working together can be another definition of that. They work together. They go together. Okay, Mason. Maybe.
I
Maybe.
think we did.
No, the only thing I remember last year is the coefficient.
Okay. So for corresponding, for this table, we'll put X values with their corresponding Y values. We will put the X values in least to greatest order. So I will put -3 first, followed by 1, followed by 7 in my table. I'm going to put -3, followed by 1, followed by 7 in my table. That way it's easier for us to read later if we organize it least to greatest by the X values. But for the Y values, we don't want to put them least to greatest. We want to match them up with their X value, with their corresponding X value. So what Y value would go with -3? 2. The one would come next. 1, comma,
4,
and 7, comma, -9. So we don't care that the Y values are in order. The Y values just have to match with the X's. The X's, though, are least to greatest. Is that why is that? Okay. So this way, when we read it straight across, we know this point is -3, 2. Just like here, we know the point's -3, 2. We know the point's -3, 2. We know it's 1, 4. We know it's 7, -9. Just like here. That's why we don't mix up both of them. But we want some system to organize it. So we organize it by the X's. Because that's what we read first. Yeah, great question. The other way we can do this, another way we can do this is by graphing. There's a fourth way, but we won't talk about that. But there's a third way we'll do it, and by graphing. So we can graph the 3 points. So go ahead and graph those 3 points. And there's nothing for you to label the points at this time because they're not named, are they? That's okay. Tobin, why don't you help me graph the first one, 1, 4.
Okay.
So where would I go?
You go up 1, and then you go. No.
Good catch.
You would go right 1.
Yep.
And then up 4.
Very good. Go right 1 up forward. Look about there. Okay? Aiden, why don't you help me with this next one? -3, 2. Where do I go?
-3, 2.
Yep.
So you go over 3. Go over to the left 3.
Okay, very good.
2.
Very good. Way to clarify that it's over to the left, because over can be either direction, right? So very good. To the left 3, up 2. Okay, 7, -9. Hannah, I'm going to rely on you. Where do I go?
right 7.
Okay.
Down 9.
And then down 9. That's going to go off the graph there, won't it? Okay. Any questions on this? Of how we can show this same relation in 3 different ways. So all 3 of these are showing the same relation. They're just showing them in different ways. Alrighty. We're going to use a couple examples of these. So, in example 1, I want you to express this set of ordered pairs, this relation, as a table and a graph. It's already shown as a set of ordered pairs, but I want you guys to make a table and a graph. Then, find the domain and range. So we had a table and a graph we made on the last one, so I want you to make the table and graph these points as well. And then I would like for you to find the domain and the range. Big bets. What are we betting?
$50.
Oh, all right. Okay, so we're going to make an XY table here. Now, you can do the fancy trim work on the side if you want to, or you cannot. Either way is perfectly fine. Okay? Now, Lainey, what was the first thing you put in your XY table?
the X.
The X's. What X's did you have? Go and listen for me.
-1, 3, 3, 4.
We have to put 3 both times here because they're 2 different points. For a domain, we don't repeat, but for the XY table, we want to list every single point. And then what did you do for your Y values, Lainey?
-6, -4, 2, -6.
Okay, I love that. So the Y values aren't necessarily in order from least to greatest, but they line up with their X's. Now, something Lainey did here, I don't know if she did it on purpose or not, but she did it regardless. When there's a tie in your X values of those 3s, you put the lower Y value first. Okay, so when there's a tie, your tiebreaker is the Y values. Was that on purpose?
Yes.
Oh, slap on the back, okay? Good luck, Mason. Okay, so that's our XY table. Questions on this at all? Tanked open, Lydia. Okay, let's go ahead and graph these, okay? So graphing them. Help me with this first one. Abby, where would we go on the first one?
On the first one, you would go left once and then down 6.
Okay, so if we're using the table, the first one would be left 1, down 6. That's what I was intending, but I did realize after I said the first one that could be confused to be 3, 2, since that's the first in the ordered pairs. But either way, -1, -6 will go down here. Help me with 3, -4. 3, -4. Okay, Tobin, can you help me with that one?
Yep. So you go right 3
Yep.
and then down 4.
Very good, right there. Okay. Reagan, help me with 3, 2.
Right 3 of 2.
Oh, nailed it. All right, Aiden, help me with 4, -6.
What?
Help me with 4, -6. Where do I graph that?
4, -6.
Yep.
Go right 4,
Okay.
down 6.
Nailed it. All right, so now we need our domain and range. We've done the table, we've done the graph. We need our domain and range. Can somebody help me format my domain? What do I need to put first?
Capital D.
Capital D, and then what am I going to put?
The little squiggly.
The colon, and then the brace, the little squiggly thing, the brace. D colon brace. Okay, domain colon brace. Now, this domain, can somebody help me know what to put here? Okay, Tucker.
-1, 3.
Very good, and I end it. Even though I have 2 different 3s, I don't list it twice for my domain.
Really good one.
This one?
Yeah.
Oh, thank you. Okay,
Looks like it's doing a fire.
it kind of does. Kind of does. All right, so then these are in order from least to greatest. Can somebody help me out with the range? Okay, Reagan, go ahead.
-4 and 2.
-6, -4, and 2. And we do an R colon with our braces, okay? Questions on this one? Alrighty, okay. Let's see here. We're actually going to skip number 2 for now.
Yay.
If you did it already, good for you. Slap on the back. You got some extra practice in, okay? Don't give me some stank eye, okay?
You did number 2.
Alrighty. So we're skipping 2 for now. We're going to turn to functions. We're on the next page. Letter E. Man, we're cruising along, okay? A blank is a relation in which every element of the domain is paired with exactly blank element of the range. So a function, ooh, nailed it. A function, it's a special type of relation, okay? So just like how maybe a special type of a rectangle could be a square. All squares are rectangles, right? But are all rectangle squares? No, okay? You guys are all in what grade? Sophomore, 10th, okay? Now, you all are in 10th grade, okay? So all sophomores are in high school, right?
Yeah.
Okay? All the sophomores here are in high school, right?
I hope.
Okay? All high school sophomores are high school students, right?
Yes.
Now, are all high school students sophomores?
No.
No, so it doesn't go the other way, does it? So a sophomore is a more specific type of a high school student, right? Okay? So same idea. What?
I was like
That was confusing?
Big.
Yeah.
Okay. Go back to the square one then. Did the square confuse you?
Totally get it.
Well, no.
I get
Okay,
it,
go back
I
to the
get it.
square one. Same idea. A function is a more specific type of relation. So, if it's a function, it has to be a relation. If it's a relation, it doesn't have to be a function, though it could be. It's a more specific type of it. Okay? So a function is a relation in which each element of the domain, those are our x values, is paired with exactly one element of the range, and those are our y values. Okay, and it might be a good idea to write that in there, that the elements of the domain, well, the domain's the x value, so an element is just one thing of it. So any x value is paired with exactly one element of the range, so one y value. And we'll learn what we mean by when they are paired with exactly one. So when we're saying determine if these are functions, here we have a relation. We know this is a relation. We just talked about that in letter D. Well, we're going to see if it's a more specific type of relation called a function. 3, 2, 4, 5, 6, 8, 7, 1. So our domain here, is all the x values. Our 3, our 4, our 6, and our 7. Our ranges are y values, not in order here, but 2, 5, 8, and 1. Does every single part of the domain go to exactly one y value? Do we see 3 going to 2 different y values? No, it only goes to 1. It goes to 2. Do we see 4 going to 2 different y values? No, it only goes to 1. It goes to 5. Do we see 6 going to 2 different y values? Nope, we only see it going to 8. Do we see 7 going to 2 different y values? No, we only see it going to 1. So yes, this is a function. And a reasoning could be each x goes to 1 y. Another way you could think about it is that no x repeats. It'll make a little bit more sense when we get to number 2.
So if it doesn't repeat, then it's a function.
Yes, that can be part of the way we'll tell. And I'll talk about it more with number 2. It's going to make a little more sense. Okay? If we look at number 2, this is also a relation. This relation is in table form. Okay? But we learned that you can express a relation either way. 2, -7, 3, -3, 3, 2, 5, 7, -9. Now, 2, the x value goes to -7, but does it go to another y value as well?
Yeah.
It also goes to 5. So because one x value, in this case 2, goes to more than one y value, -7 and 5, this one is not a function. That's not a function. And if I wanted an explanation, if we wanted to explain it, we could say a couple of different things. You could say 2 repeats. You could also say 2 goes to -7 and 5. Okay, those could be 2 different ways of saying that. It's not a function. Why is it not a function? Well, 2 repeats. 2 goes to both -7 and 5. It can only go to one y, but it goes to 2 different y's. That's not okay. Does that clear that up a little bit more on why 1 is a function but 2 is not?
Yeah.
Yes.
Mason, you still look confused.
Well, I don't get it.
Okay? So a function, we're going to think of the x's as inputs, is what you're putting in. The y is our output, is what we're getting out. You go up to a vending machine. You put in your money. You push the button. And you expect to get out whatever for the button you push, right? If you push F4 and it says Reese's, you're expecting to get Reese's, not a Snickers, right? Okay? Now what would happen, that's like a function. Now what would happen if you were to push F4 and you could get either a Reese's or a Snickers? Like what happened if there were 2 F4 spots? That'd be weird, right? That was not how vending machines work. That'd be the same kind of thing. This is right now, like there's 2 spots for the same button combo. So if I push F4, we don't know what we're getting. If I put in 2, I don't know if I'm getting out -7 or 5. So it's not a function. For it to be a function, you have to put one thing in, one x in, put in one x, and you have to get out a specific y. The moment you have it not being specific, it could be -7 or 5. We don't know. It's both. It's no longer a function. Does that clear that up at least? Okay, good. I like putting things in terms of food and money. Okay, it works. Okay, let's look at number 3. 3, 2, 4, 5, 6, 8, and 3, 1.
No.
Not. Why is it not a function?
Because 3 goes into 2 and 1.
Okay, so I heard a couple different ways there. Okay, 3 repeats. There's 2 of them. Okay, another way we're saying
Wait, so
3 goes
the 2 things?
to 2 and 1. What was that?
So it can't go into 2.
Yep, so 3 can't go to both 2 and 1. That's the same scenario here. We push F4 on the vending machine. It could go to 2 different spots. It's just going to pick randomly each time. We don't want that vending machine. It's not a function. Get it out of here. It's still a relation, but it's not a function.
Does this still go for even if they're a Y?
Great question. Does that still count even if it's the Y? So can the Y's repeat? The Y's can repeat. The X's can't. So we don't care about what the Y's are necessarily. We really just care about what the X's are for this. Okay? So if I were to just give you an extra random one, okay? And I were to say maybe number 4. Okay, number 4. Okay? And I gave you this function, x, y, and I give you, I don't know, -1, 5, 2, 0, and 3, 5. Okay, this is a function. Even though 5 repeats, it's a y, we don't care. None of the x's repeat. So you see how in vending machines, or in a lot of times, it might have two different spots have the same candy. Like you might have 2 different spots be Butterfinger, because they're good. Okay? So, that's okay. We can push 2 different buttons and get Butterfinger. It's like putting a -1 and 3. You get Butterfinger out of both. You get 5 out of both. That's okay. But you just don't want it the other way around, where you push 1 button and we don't know what we're going to get. Does that make sense? Okay, Y's can repeat, X's can't. All right, continuing on. Letter F, the vertical line test. F is the vertical line test. If any vertical line, vertical is which direction? Show me with your hands. Okay? Vertical is this direction, up and down. Everyone go up and down with their hands right now. Everyone go up and down with their hands right now. Everyone go up and down with their hands right now. Everyone go, there we go.
Do it.
Okay. So if any vertical line passes through more than 1 point, the graph's not a function. Examples, determine if this relation is a function. So if I start drawing vertical lines, and I say right here, it doesn't hit any points. Well, that's okay. It says it has to hit more than 1. Right here, it hits exactly 1. But what about right here? How many points does it hit on the graph? 2. So does it hit more than 1? Yes. So according to this, if any vertical line passes through more than 1 point, it does, then it is not a function. So is this a function?
No.
No, not a function. And you want to know what my explanation could be? Fails the vertical line test. Fail the vertical line test. Either passes or it fails it. So if you have a graph, just start drawing vertical lines. Now notice I had to draw multiple vertical lines here, right? Now if I had started over here, if I had started on this left side, would have I had to draw multiple? No. We don't care that some of them pass at all. If you have even one that fails, it fails.
Wait, how did the...
So it fails the vertical line test. It fails it, in air quotes, because it hits more than 1 point. It hits here and here on the graph. Okay? On this next one, I want you guys to try it.
It could go either way.
I want you guys to try it. So number 2, it failed it. Did not pass the vertical line test, as we saw there. Even though some lines did, some lines didn't. So 3. Oh man, we'll just do this one up here. I love this, okay? Maddie, what do you think? You think it's a function? All right, I agree. It passes the vertical line test. There's nowhere we can go where we can draw a vertical line that's going to hit more than 1 point. We don't care that it hits none over here on the left-hand side or the right-hand side. But we care that there's no place where it hits more than 1. So, yes, it is a function. It passes the vertical line test. Questions on that? Dang dope and let Okay, continuing on. Letter G, our last one. Last action. Woo! Reagan's clapping. We're happy. Okay? Reagan just really loves the letter G. Okay? So, we're going to practice substituting values. What does substitute mean in math?
Change.
Change. Or substitute in general means change, right? If you're playing, volleyball, what would substituting mean?
Showing up to the tempo line and then.
I don't know what volleyball.
You're getting switched out or switched in. People are switching in and out. Okay? Same thing with any sport. Football. Okay? Any sport that substitutes. Guess golf, you don't really substitute.
This is so
Okay?
Yeah.
Dope. Okay? But now notice, here's the thing. Laney in volleyball. Are you going to substitute in, a defensive specialist to go play outside hitter?
Yep.
Probably not. They play different positions, right?
Yeah.
You're going to go sub in an outside hitter to play outside hitter. You're going to go sub in a middle blocker to play middle blocker. In football, Mason, are you going to go sub in and play center? What position do you play normally? Left guard. Okay. Are you going to go sub in and play quarterback? No, you don't want your lineman throwing the ball. You don't want your quarterback blocking for you. You don't want that. That's bad juju. Okay? You want to substitute in the same value. Okay? The same thing. Okay? You want to make sure you're subbing in the same spot. Okay? It's very, very important. Okay? Band. Think about band. Okay? Or marching band. Are you going to take someone who plays the tuba or the sousaphone for marching band and have them go twirl the flag and throw the flag up?
Yep.
Probably not. It's not going to end well. Or vice versa.
I mean, they could.
Probably not going to end too well. Okay, Aiden? It's not. It's just cut there so that way we can get up in the ceiling. Anyway, so when we have this on number 1, guys, that y equals 2x plus 1. How many different variables here do we have? 2. We have y and x. That's why I'm going through the substituting thing, because it's important that we make sure we substitute the right one. If x equals 2, what is y? If x equals 2, so what variable can we substitute 2 for? X. Can we substitute for y?
No.
It's not the same thing. That'd be like substituting an outside hitter to go play defensive specialist. You don't want that either.
No.
Okay? Lainey's giving me like, no, okay? You don't want to substitute your pitcher in softball or baseball in to play catcher. You don't want that. Okay? You don't want your lineman throwing the ball. No offense, Mason. Okay? You don't want that. Okay. Cool. Okay? So y equals 2x plus 1. If x equals 2, what equals y? So what we're going to do is we're just going to rewrite this exact same thing, because everything else stays the same when you make a substitution. You just change out the one thing. We take out the x and we're going to put in
2.
the 2. So we're going to put y equals 2. What is 2 doing with x?
Times.
Times. So what's 2 going to do with 2?
4.
It's still going to multiply to get 4. So we're going to put 2 times 2 plus 1. Now you'll notice, whenever I substitute, I'm going to put that in parentheses. Remember we talked about this before, right? Okay, we practiced substituting when we checked our work, didn't we? Okay, so now we say, well, what is y going to equal when x is 2? Well, 2 times 2 is what, Hannah?
4.
4. So y equals 4 plus 1. And Aiden, what is y equal to then? 5. So if x is 2, y is 5. What would we have done if it said when x is negative 3? What would we have done if it said when x is negative 3?
It would be -5.
We'd plug in negative 3. And we'd end up getting negative 5. Very good. Okay? That was some good quick maths. 2 plus 2, that's 4. Minus 1, that's 3. Quick maths. Okay? Man's not hot. Okay? Number 2. Y equals 3x minus 2. Find y if x equals 1. Okay? Y equals 3x minus 2. Find y if x equals 1. I thought you might like that. Okay. So, can somebody tell me what to write here?
Y equals 3 times 1 minus 2.
Y equals 3 times 1 minus 2. Instead of x, we're going to put 1 in. Okay, what is 3 times 1?
3.
3. What is 3 minus 2?
1.
So y is 1.
Yes, sir.
Yes, sir.
It's confusing.
Alrighty.
Try.
Is 4, 6 a solution to 3x plus y equals 30? Okay, well, wait, what's this mean? Okay, this is a lot different. Okay, well, wait, is it? So we're saying that the ordered pair on number 1, that the ordered pair 2, 5 is a solution, because 2 is which value, x or y? Which, or in the ordered pair, which one would 2 be? 2 would be x, 5 would be y. Well, x is 2, y is 5. It's an ordered pair. So if I plug in 2 for x, 5 for y, well, we would end up getting it to check out, wouldn't we? Because y was 5 when x was 2. Well, same thing here. The ordered pair for this would be 1, 1. So we're just asking, is 4, 6 a solution to 3x plus y equals 30? Where are we going to put this 4 at? The x. Because it's x, y. Where are we going to put the 6 at? The y. And we're going to plug it in, and we're going to check. We practice doing this a lot. So instead of 3 times x, it's 3 times 4 plus 6. And we're going to say equals 30. We're checking to see if it works. If it does equal 30, then yeah, 4, 6 is a solution. If it doesn't, then it's not a solution.
Wait a second, what is 7 and 9 though?
Well, that's another question. Notice question mark, and then it says, well, okay, now what about this? So we do this first, then we say, okay, well, second question.
I didn't get.
Is this a solution? You didn't get any? It doesn't make sense?
No, like I didn't.
It's not a solution.
Okay, so 4, 6. 3 times 4 is 12. 12 plus 6, that doesn't equal 30, does it? So is 4, 6 a solution? No, is our answer. And this is our work proving it.
Oh, that makes sense.
So now we're asking, okay, next question. Is 7, 9? Is 7, 9 a solution?
No.
So how would we figure that out?
Just said that plugged in.
We plug those in instead.
Oh.
So 3 times 7 plus 9 equals 30. Remember, it's always x, y, so the 7's for the x, the 9's for the y. What's 3 times 7? 91.
Not it.
Plus 9. What's 21 plus 9?
Oh, wait, I thought it was 20.
Ah, does 30 equal 30?
I thought it was 20.
So, is 7, 9 a solution?
Yes.
Yes.
Can we be done now?
Now, in this case, when we did one variable equations, when we just had one variable, before we pack up, guys, when we just had one variable, we only had one solution, except for our rare cases where we had no solution or infinitely many. In this, you can have a ton of solutions. You can actually have infinitely many. So like 7, 9 could be a solution. You could have another solution as well, okay? You could have 10, 0 be a solution, okay? You could have 9, 3 be a solution, okay? You can have all sorts of solutions, okay? You can have 8, 6 be a solution, okay? All sorts of these. But in this case, we're checking to see, was this one? Okay, questions on that?